Okay, first of all, before we begin, obviously you can see we're having a bit of a build day today. We're going to try and get a bit more work done on the cloud chamber. I'll explain what we're going to do with that a bit later on, but we've also got to put a couple of muon detectors together. We've got to order a couple of Geiger counters. I just thought I'd show you what's on the screen. As you can see, this is the count that's been taken right now. This is the background count, really the one that you should pay attention to. As you can see, 0.14 microsieverts, so very, very low. If you saw a 5 at that decimal point there, then you start to get concerned, but you can see it's well below anything hazardous at the moment, and it's been like that for a good month now. So we're going to order a couple more of these for the package that's going out in January. We're going to build a couple more magnetometers using the Arduino and the magnetometer chips. And we're also going to put together 2 more of these muon detectors, and then we're going to do a bit more work on the cloud chamber. Just want to say a big thanks to those people that are supporting this, because as you can see there's quite a few components here that we purchase, and the cost of these components aren't cheap in some cases. Just for one of these components to build the muon detectors is £80. That's the silicon photo multiplier that goes on this PCB here. And then you've got £30 for your crystal singulate that goes on there, as well as all the other components that fit on this larger PCB. The smaller PCB here is just for your micro SD card. But neither of these SD cards, in the ones that are going out January, will be part of the circuitry, because we're not interested in collecting the data, but more so what's coming off on the LCDs, so that the people that when they receive these in either Brazil or South Australia Central will just be able to look at the screen on the LCD, and they'll see how many counts there's been over the time period, and that's all they need to relay back to us here at the observatory, and we can then put that up on the website. The reason why we're putting these out is, as you know, because we want to know how much radiation is in the low intensity region of magnetism on the Earth, which is the South Atlantic anomaly, where Brazil or South Africa's one will go. And then we were looking at the high intensity region in the south coast central of Australia. So big thanks to you guys that are out there supporting this, and if you want to help us what we're doing here, there's a link down there. Like I say, guys, we don't just talk about these things, we actually get out there and build them. And you can't buy some of these components. We were very lucky, we managed to get the PCB files and the build documents to support the building of the muon detectors. So we've got some state-of-the-art equipment, and on top of that, over the next month or so, we're also going to add that oxygen sensor so we can monitor atmospheric oxygen. So there's a lot involved. So I'll just give you a quick rundown what we're going to do today. We've got the cloud chamber Peltier array disassembled from the water reservoir and pump. As you can see underneath there, we'll just zoom in, there's a water block that circulates the bottom Peltiers, which are run at 12 volts. And then in this stack here, if you remember the last time I've done a video on this, we've got 12 volts on the bottom Peltier. Then the next Peltier, which you can see in the centre there, is running at 5 volts, and then the one on the top runs at 3 volts. So it gradually takes the heat from the surface all the way down into the water jacket, which is at the bottom, or the water reservoir, circulates it round some fans to cool it, and then pumps it back through from the reservoir to the water jacket at the bottom, or the water block, in turn keeping these Peltiers as cool as we can. Now with the top Peltier, we managed to get around minus 36 Celsius to minus 40 on some occasions. So I'm hoping that when we put the rest of these Peltiers on there, we'll get the desired temperature or the target temperature of minus 40 degrees Celsius. But as you can see, there's quite a few wires to sort out, and we've got another power pack now. Hopefully this power pack will be a lot more powerful than the original one, but we're going to run them in series with each other. So one will be powering some of the Peltiers, and the other one will hopefully repower the rest of them that we've got here. So before we start putting the peltiers on, we've got to use some thermal grease to cement them on so that the heat transfer moves from the top peltier all the way down to the bottom one, and then gets cooled by the water blocks and in turn circulates around the fans, and then it should pump cooler water through the system. The other thing we're going to do, I'm going to add ethylene glycol or antifreeze to the water, and that should stop the water going a bit mouldy, because I noticed that the water started to look a little bit discoloured. I could have put a bit of bleach in the water, but I'm going to use ethylene glycol, and that should keep the bacteria down that builds up in the water tank, and it should also help as well keep the blocks cooler. So with this power pack, obviously I've got to sort out that green wire there that you can see, and that gets earthed. If ever you're using power packs for projects, you need to sort out that green wire on the the loom, and just connect it to a black one, which is a ground, and then the power pack will supply power to all the other wires. And the nice thing about using computer power supplies is that you have the 12 volt, the 5 volt and the 3.5 volt all in the bungle of the loom there, so it's easy to use. So yeah guys, as you can see, we've got quite a bit of work to do today, and I'm going to get on with that, and I'll show you how we get on throughout the day. But I don't think we'll get everything done that we want today, but we'll certainly have a good go. We've still got a bit of time till January to make sure that the muon detectors are assembled. These should have come by then, another 2 of these, because they'll all be going out in a package. So we'll be sending a muon detector, a magnetometer and the Geiger counter out to those 2 locations. And meanwhile we'll put a bit more work in on the cloud chamber, and the whole idea of having this cloud chamber is so that we can get a visual of elementary particles passing through an alcohol vapour above this plate, which will be around about -40 degrees, and it will show us the trace of these elementary particles as they come past. And if we're lucky, we might see a cosmic ray come through there and strike another particle, and we'll see what happens with regards to that strike. So yeah guys, I'm going to get stuck into it, and I'll probably see you a little bit later on in the video. A little bit longer than what I thought, but when you consider there is 18 peltiers at 3 different voltages, the bottom one is running at 12 volts, the centre one is running at 5 volts, and the very top one is running at 3.5 volts. I've tested it already. We're getting good results. We're getting it around about -35. We have got one of the peltiers in this stack here not performing quite as good as I'd like, so I'm going to break this pack apart, find out which one's not working, replace it. Luckily enough, we have got some spare peltiers, so we can do that. You can see that the power packs look a little bit different to earlier. We've stripped off what wires we wanted inside and just kept what we needed. What we've done, in order to run all 18 peltiers at the same time, we've had to share the power between the 2 power packs. So this power pack is just running the middle 6 and the top 6. So we're running 5 volts in the middle and 3.5 on the top, and that's controlling that power. This one's just running the 12 volt ones on the bottom, because they'll be drawing most of the current. We tried to run them all off the one power pack, and it just weren't enough to do it. Just kept shutting down because we was just draining the power out of it. So what we were running off this power pack is the pump for the water reservoir and the set of fans on the radiator. So I'll switch it on and I'll show you what we're getting right now. Like I say, we had around about 35 degrees minus, which is 10 degrees more than what we need. At the moment we're running the fans very close to the peltiers, so that will have an obvious effect, drawing room temperature constantly over the top of the peltier will reduce the performance. So when we put all this in a box, we'll make sure that the fans are not drawing room temperature across the peltiers, but this environment here will be in its own contained tank in any case. So we'll just let that cool down. We'll see where we're going at the moment with regards to temperature. We're at -14. 25 to 27 is an ideal temperature for us. we'll start to get cosmic rays visible at that temperature. So, you know, with the performance I'm getting right now, you know, I'm happy that we'll see cosmic rays, even if it's at this poor standard. But you know, it will slightly improve when we move the fans out of the way of drawing, you know, the room temperature over the Celsius. The other thing is, in the reservoir, we're going to put ethylene glycol. That will help again, just improve the performance just that little bit more. So let's have a look where we are right now. Minus 24. So right now, at this temperature, it's good enough. We're at minus 27 across all of them apart from this one. This is our lazy one here. As you can see, it's just running at -1. So I take it that one of the peltiers in that stack is either not connected properly or it's malfunctioned. So we'll whip out that faulty peltier and put that right. But all the others seem to be running well. We're almost at minus 30 there. There we go. The others do catch up eventually. Still dropping the temperature. Minus 31. Minus 32. Like I say, on its run earlier, I got it down to minus 36. But you can see condensation straight away on the peltiers. You know, starting to get ice form on them. And even at that temperature that we're getting now, even though it will be slightly improved when we haven't got these fans in the vicinity of the peltiers, you know, we'll have an improvement there with temperature going below minus 35, and when we get the ethylene glycol in the tank, that'll also help keep the temperature down. So let's just have a little check of what we're at the moment. Still minus 30, minus 33. Still dropping. Like I say, it does go down to 35. I won't bore you waiting for that to happen. You know, we're nearly there, as you can see. Just about nearly. Oh, here we go, 34. So yeah, you know, a couple of little tweaks and we'll have this ready. And you know, like I say, it took a little bit longer than what I expected it to today, but we've got the power pack sorted out. We've got the power supply now powering the pump, the reservoir and the radiators. And like I say, I want to try and get this finished and completed for, you know, mid-January. There's still a bit of work to do. We've got to find, you know, a nice casing for it all to go in. But when we're finished, we're going to get some brilliant results, you know, from, you know, these cosmic rays that we'll see coming through our atmosphere. So not only have we got neon detectors detecting them, you know, we're going to get a visual on them as well. So not only will we see an increase over the coming time with cosmic rays, but we'll also see visually, hopefully, an increase. We've got about 10 by 30 centimeters viewing platform, which is, you know, bigger than some of the cloud generators that I've saw. It's not the biggest, but at the end of the day, we're using a bit of a unique way of bringing the temperatures down. Probably not the most efficient way, you know, but the nice thing about this is we'll be able to switch it on and get those temperatures that we desire and get a result straight away, and we can do that at any point in time, as opposed to using, you know, dried ice. You've you've got to go and locate it, and then you've only got a limited time before it completely evaporates at room temperature. So yeah, that's probably all we got time for today, guys. There's a link down there. Obviously you can see we don't just talk about these things, we actually get out there and build them, and all this has a cost. So if you want to help contribute towards some of the costs that we've got here at the observatory, then please feel free to use the links down below. And also what I usually do, and have a great weekend, great week should I say, and I'll catch you at your weekend. Bye for now.